All right, so in this video, we're going to talk about, we're going to go over the Xcache DPOPS code. This will be a little technical video, but we're basically going to explain like how it was built and all that. I thought this would be interesting to kind of go over. So this will require some, technical knowledge. Warning. So uh, let's get started on this one. Hopefully this will go quick. Um, so essentially we got scripts. Here's our auto installer. Um, this thing is just basically a bash script. You take a look at it. It's a pretty lengthy one. It comes out to be 2,000 about 2,000 lines, and it just goes over. It basically just auto installs and lets you auto update and grab the blockchain and all that good stuff. Builds basically for me, just different build tools, firewall, system D scripts, and then virtual machine scripts. These are basically scripts I use for my virtual machines when testing. Um, so then let's get to the real code here. Test, we'll go over these first. Tests are just basically unit test. So each file has basically a unit test. The code's about 90%, if we had to guess. The coverage. We have a tool, but it for some reason can't read it directly. And then when you read it off of GitHub directly, that won't tell you how much it's code coverage. So this is a guess here because that tool's not working for some reason when you run it off a server. But essentially, it's about, I would say, 90% because it checks pretty much everything. And it just checks like sign the data, send the data, and there's different data it's sending to each route kind of, and then checking for that response. It checks for errors too. That we actually, if we send an error, we should get that particular error back. We don't really need to go over that, but essentially that's all it's doing. This took a while because sometimes you have to sign stuff out of the wallet. So you have to hand sign things out of the CLI wallet and just different stuff like that. So it took a while to build, but I would say these were very necessary. And we even, built a little bit more unit test in during the DPOPS alpha because we noticed, okay, like, we're going like 2 weeks. We had the same problem. This is going to take forever. Let's build out. Let's take a 1 week, 1 week pause kind of. Let's build the unit test and let's come back. And that totally, I think, saved maybe a month or two by taking a week here and there when things would take longer than 2 weeks. So I would say that saved us a lot of time because the first like month or two of we weren't doing that, and it was dragging on some areas. So the unit test really helped. We have about 451 of them, I think. When we started alpha, we only had 250. So that tells you how much we did during the alpha. Also, the auto installer was not even there when we started the alpha, and that was a quick learning that, wow, okay, we need an auto installer for this because it's hard for everyone to install. So let's get into this. We've got the global data. These are just like header files. These are like the CryptoNode config in Xcache core, if you wanna call it that. It's a little bit bulkier in my opinion than CryptoNode config, as you can see. But these are basically all the things you can change, parameters and stuff like that. It's also got all the test nodes on it that I've run, test setups and all that with 10. I think it does 5 virtual machines, 10 and 15 and 20. And then it's got just some messages and stuff in there. It's the same thing, a header, but it's for different functions that I use. if you know C, it's basically these aren't functions. These are like drop and replace, like replace text. That's how this works with a define macro. Um, so that's essentially what these are. This is basically a header file to keep all those functions, I guess you want to call them, but they're not functions. This is the same thing. Initialize. I have different structs that I like to initialize, so it was nice to just keep these in a function or in a header file, and then you just call these wherever you need it, so you don't have bulky code all over the place. Really, in C, you get the problem with C is that there's bulky code all over the place. That's just it's unavoidable because you have to do a whole bunch of stuff with C, and it gets really bulky really quick. So what I do is I use define macros. I use that a lot. That way, it looks like JavaScript time, where it's like really tight and clean code. You can write that in C if you just use define macros a lot. So that's what I'm doing here. Structures, obviously, we hold our structures. These are like classes. In any other language, these would be called classes, but they're called structures because they're limited, very limited classes. But that's essentially what they do. They're just a container to hold multiple variables. And then you got your global variables. Yeah, I know global variables are not a good thing usually, but there was a few we needed to use to make this go a little bit quicker. And yeah, we're using some global variables, as you can see. So let's get down into this. We're not going to go for every function, but I just want to go over like the layout. That way, if someone's coming, someone wants to learn or build off of this or whatever, as long as they know the layout, the general layout, we're not going to explain how everything works. We'd be here for a month, but we're just going to go over the general layout so you know where things are. So this is server functions, and what this does is it's basically these are messages that you'll get from a node. So the server's built to hold or to respond to GET requests and raw TCP requests. So these are all raw TCP requests. So when that comes in, it's routed to one of these functions. And then one of these functions runs the message, and then if they need to send data, they'll send data back. If not, then they won't. Now we've got, let's just pop some of these open. Synchronized check functions. These are basically just to check if your blockchain, or not your blockchain, your decentralized database, if it's synchronized, it's just checking to see if it's synchronized. Not much to explain there. Synchronized server functions. So now these are basically server routes that are all for syncing the decentralized database. So they're the same as this, but these are for actually like doing the actual DPOPS, and these are just for syncing, sending back and forth the database. Synchronized functions are basically when your node needs to sync his database. That's his decentralized database. That's basically what this is. There's also this big function is a DBFT check between the 5 seed nodes to make sure they have good data. And then all the rest are just syncing. Then there's this, which is thread server functions. These are basically thread. So these are basically timer functions, if we want to call them that. So anything that runs on a timer is going to be in here. The current block height timer, just different stuff like this. So all of these are timer functions. Or this isn't a timer function, but it's a function that runs inside of a timer function down here. So that's basically, these are all timer functions. If you need to know where the timer functions are, they're here. The update functions, this is basically the update after a round's over, basically updating the stats and all of that. These are these are those functions, and you can see why this, number one, it took a while, and then number two, why this is like a 50,000 line program, because it's just so massive. I'm trying to find a good example. If we can go back, yeah, let's go here real quick, and then we'll go back. So then block verifier functions. This is where everything happens. This is basically the core, like the main, I guess you would call. It's not the main, but this would be like the second main if we could have that. Um, this is basically where the round runs for the 5 minutes and what happens, and it controls everything. And so this is basically a main key part. And this is where you understand how the rounds work and all that stuff. I really quickly want to go back to this one real quick. As you can see, what I do here to make this code clean is I do a error define macro where I, put it in the error if you're running the debug settings, and then, do whatever, send data, blah, blah, blah. That way, when you have an error, you know how you usually just do like throw error or something like that in JavaScript. So that's kind of how this goes. Like if an error occurs with these functions, just error, error. So that way it looks cleaner, because like most C code just looks bulky and it looks out of control. So I try to keep things really like clean when coding this stuff. Because I want to, I don't want to come back to this later and be like, well, whoa, what was I trying to do here and stuff. So, and this is open source, so it's good to look, it's good to be presentable and have other people be able to dive right in. So now let's go to blockchain functions. This is basically where like heavy, like low level blockchain functions happen. So like we're doing, variant encodes, and the big one is this one. We're converting a struct to a string of blockchain data, and then we're doing the opposite. We're converting this, blockchain data to a string, and then we're verifying the block. This is where the big one is on verifying the block. So this is where like when the block producer sends you a block, and you're like, okay, like we all got the same data. Like we could have just built this and said, okay, 67% of people have the same data. It's good. The problem with that is that because this is a second layer, and this is kind of important to understand, because this is a second layer and it's running side by side with Xcache core essentially. There's a situation where, a block producer sends everybody an invalid block, but he sends everybody an invalid block. Then everybody gets the block. They just say, okay, we all got it. It's over 67%. Let's add it because we all got the same result or the same thing. Then when it would be pushed to Xcache core, it would then have an error in there. And then we'd have a problem because it's like, then Xcache core would have to tell, Xcache DPOPS, like there's an error. So essentially, this is what this code is. It basically will do the exact same thing Xcache core is going to do. This took quite a while because it has to check a whole bunch of stuff. And then it also runs through the signatures to make sure that at least 67 people signed it. And it basically will make sure that if this passes, it will pass in Xcache core. So I spent a lot of time in this file. Then you got database functions. We're not going to go over those, but it's just these are all the database functions: count, deletes, insert, read, update, and then just random database functions like checking if it exists or getting the data, getting the database data hash, just different stuff like that. Then we got delegate website functions. So these are server routes that respond to GET requests. So it makes it really simple. These are for the delegate website only. So this is basically what the seed node's running. That's about it. So this is where that file is. File functions, we're not going to go over that. It's just like read a file, write a file. network functions. Network daemon functions are obviously functions that work with the daemon. And wallet functions work with the wallet. And then we got security functions. This is basically where you sign the data, because remember, we're signing with our key essentially, and then we're sending it to others. So sign, verify. Um, that's basically what this is. We don't need to go into that. And then network functions itself. Um, these are like send data. This is how all the data is being sent. There's how you send a post request, how you send a raw TCP data, how you can send and receive raw TCP. So this is a very low level where all the networking stuff's happening. So then we have organized. We'll go into this one because it's hard to explain. This is where basically all of this 500 lines is just basically how we organize the delegates on the website essentially, and well, the website, but also in the database. This is how they're organized by vote count and all of that. So a bunch of functions just do basically one simple thing at the end. Server functions. So delegate server functions. So these are the functions that run when your wallet connects to the um, delegates and basically does something. So like when you do like delegate register, delegate update, delegate vote, that's this is the piece that it's communicating with. So there's all that stuff. Server functions in general. This is a large one. This is basically where that ePOL server is created, where the multi-threaded workers are created, and all of that. Obviously, we don't really need to show that, but that's just where this server is being created, and then socket threads are running. And it's delegating to each thread. Okay, here, 5 messages came in. Okay, you take this one, you take this one. The one thing we will show is the router. Basically, this is like the router table that basically says like, if the message is this, run this function. If the message is this, run this function. So as you can see, there's lots of functions in DPOPS. And this is basically like the router table, essentially. Now let's go to this one. Let's go to this one first. This is shared delegate website functions. So again, these are GET requests that only interact with the shared delegates. So these aren't even running on yours if you're not a shared delegate. Then these are shared delegate thread functions. So timer functions is what I'm trying to say. And the only timer function that it has is basically check if I produce the last block, and then check every hour when I need to pay people. So those timer functions are in this file. String functions, we have some core string functions like parsing JSON data. Remember, this is not using any libraries, or it's using like core libraries like pthread and like the database, and math and stuff like that, but it's not using any like external really. Ones you would download on GitHub and stuff like that. So, parse JSON, convert arrays to JSON data to output them to the browser. We got some really core functions like string replace. It's crazy, but C doesn't actually have its own string replace function. And just different stuff like that. We don't need to go on this anymore. Thread functions, these are not even used. These are something I wrote early back in like January of 2019. These are basically like wrappers to make functions multi-threaded. That's essentially what this is, but then I realized like I didn't need any of these. Luckily, they're very small. They didn't take up that much time. But these aren't used at all in the code. They probably should be deleted, but I don't know if I'll use them in the future, so I just kept them. And then VRF functions. These are basically the VRF. The one. I guess it's not really a library, but the one like external code that we're using is for the VRFs because I didn't. It's probably not safe to just write your own, and then basically on top of that, would have taken forever, and it would have been nonsense, a waste of time for no reason technically. So these do all that, but I did have to write basically a function that communicates with these. Really, it's just creating the random keys, generating the random keys, signing the network, signing the block before you send it if you're the producer, signing and verifying data with the library, or not the library, but the external code. And then yeah, that's about it. So then the last part would just be main, essentially. So then you just declare all the variables. We're initializing all the data when it starts. We're basically initializing all the global variables. We're getting the public address, the block height, all that stuff. We're starting, we're checking any parameters here that you've passed in. We're printing out all the settings that you have. We're checking if your database is synced. And then we're starting all the timers. And then we're sending it off. That's basically what this is. So yeah, this is where we'll stop because there's nothing else to show. So yeah, so that's basically it for this video. But I just wanted to quickly go over where everything's located. That way, contributors can say, okay, I'd like to learn more about X. So at least I know it's in file Y. Let me just go to file Y, and then I can read about X. So yeah, that's about it for this video, and thank you for watching.